And welcome back to another exciting edition of Mr. Hall's Virtual Classroom. I'll be your host, as always, Mr. Hall. Alright, my dear sweet friends, it is a time for another class. Whoa, what was that? Okay, that was weird. I'm gonna need you to get out of here. Okay, that was really weird. All right, but if you'll join me, we are gonna be on page 357 for section 9.3, the functions. So we've kind of touched on both functions and relations. Previously we did relations, and now we're gonna mainly talk about functions. So a function is a relation in which ordered pairs have the same first coordinate, meaning first coordinate would be like if it was 2, 2, you had one that was 2, 1, and 2, 3. Using this for reference. Which one do they share? Anybody? Oh, Mr. Hart, they both share the 2. Well, thank you. Thank you so much for telling me that. I really appreciate someone stepping in and answering questions. So we're going to learn about making a Venn diagram for plotting domain and range. Stop it. I'm trying to teach a lesson here. Oh, my word, my word, my word. So let's go ahead and look here, if you could, at example 1. It says, make a circle map of the relation to C. Alright, so I want you guys to go ahead and look where it says C equals. Alright, we're given an ordered pair. Remember, X comes first, Y comes second. So guess what in your circle happens? X will come first and Y will come second. So I'm going to go ahead and draw me. I'm going to do 2 circles here, and I'm going to put D and I'm going to put R, so that way we'll know what goes what. So we're given -3, 2. So what I want to do here is I want you guys to look. All right, if you will look at where it says C equals, how many times do we see -3? Just one time, so we can put -3 there. What's our next? -2. Our next would be 1. We have a 3. And we have a 4. Now let's look at our range. We have, and again, most of the time you want to put smallest to largest. So -3 would come first. -2. Let's see what would be next. 3. And 4. Well, that's weird. How come the first one has 5 and the other one only has 4? I'm glad you asked. Because you are not going to let, you don't have to have numbers repeating themselves. So there was 2 3s in our range, so you can just put 3 down one time. Alright? Now we're going to go ahead and pair these guys up. So let's go ahead and write our domain in circle 1. So that would be -3, -2, 1, 3, and 4. -3, -2, 3, and 4. Now guess what we're going to do? We're going to draw arrows indicating their matching pair. So where does -3 go to? -3 will go to -2. So -2 connects to 3. 1 goes to -3. 3 goes to 4. And 4 goes to 3. So if you notice, -2 and 4 share 3. And that's okay. So that's why we only wrote it one time down here, okay? You don't have to write it twice. So again, all we did, this is your domain on this side, and this is your range. Alright, let's look on example 2 if we could. Example 2 says, determine whether each relation is a function and explain your answer. So we have m and n, and these are two separate ones. We're only going to do one. So here's the way that you're going to know if they're a function. If two ordered pairs have the same x coordinate. So what I'm saying is no two have the same x coordinate. That means if you had x and y right here, and one of them was 2, 3, we'll make this 4, 3, or 4, 2, and if we had another 2, 1. This would not be because there are two being shared. Alright? So this would not be a function because there are two being shared. But if I had something that looked like this, if I was given 2, 3, 4, 2, 5, 1, are any of my x's the same? No, so this would be a function. Because they're shared right here. So when you're looking and it asks you if they're a function, look for ones that are being shared. So if you'll look on example 2, would A be a function? Yes, because none of the x's are the same. What about B? No, because 2 points have positive 3. Alright? So on B, 2 points in the x share 3. So no, it would not be. The first one would be because no points are the same. So be mindful of looking at your x coordinates first, okay? Join us on the next page, if you will. We're going to go ahead and look at example 3. Example 3 says, is P a function? Well, let's take a look. Let's see if does 2 points have the same. So I'm just going to write them down so we can look here. P, we have -3, 6, 1, 6, and 2, 6. Is it a function? Yes, because no two x points are the same. No two x points are the same. 3, 1, and 2. But that's weird. They all have the same what? Y. But that's okay. They can have the second coordinate. It does not matter. But they cannot share the same horizontal line. So remember, x always is horizontal. Y is always vertical. So it's okay right here to have the same. I mean, they can't have the same here to be a function, but it's okay for these to be. So remember what I say, always look toward the x and make sure that they are not the same in order to be a function. Alright, so let's go ahead with that being said and take a gander, if we could, at example 4. Example 4 says for us to find each of the following values for the function. So what we're going to do here is, well, first of all, I want you guys to, if you would, read above that example 4 where it says, the domain of f is -3, 0, 3. Domains always are x, and the range is -2, 3, 4. So those are making the pairs. And it says right here, we say the value of function at f, 0, is at 3. You can abbreviate for standard function notation. Alright, so what we're going to do here is we're going to take, it says we're finding the function of g, okay? So g is going to be our x, alright? So we're going to take 1, so this is example 4, and it says g equals -1, 1, 0, 2, and 1, 3. So that means when we're looking at A, B, and C here, that means you're going to take 1, 1, 0, and you're going to get g of 1, g of 0, because you're pulling these from your x, and g of negative 1. Alright? So when we put g of 1, we're looking for what they're paired to. Alright? So g of 1 equals 3 because it's paired with 3. So where did I get the 3 at? Well, here's my g of 1, and this is the 3 it's paired to. So g of 1 is paired to 3. So it equals 3. G of 0 is paired to what? 2. So it's 2. G of negative 1 is paired with what? Positive 1, so it equals 1. And that's just our function rule here when it's asking you to find the following values. It's talking about what it's paired with. Okay, so again, my g of 1, which came from right here, is paired with 3. G of 0 came from here, it's paired with 2. G of negative 1 is right here, is paired with 1. And that's how we find our function. Example 5 says, find each of the following values for f of x when it's 2x plus 4. Easy peasy lemon squeezy. Alright, so we are given f. You know what's kind of crazy? They're actually doing this in Algebra 2, and we were doing it in Pre-Cal. I mean, obviously it's scaled down a little bit, but you guys are doing the same. It just blows my mind you're doing this in 8th grade. Alright, so we got f of x, which f of x stands for a function. Also, little quick tip, also stands for y equals. That way, if somebody asks you, you'll sound smart. (2x plus 4). So it says we're given f of 3. So f of 3 is going to go in our x place. Alright, so that's basically saying 3 is taking the place of x. Well, guess what it does over here? It takes the place of x. So you now have 2 times 3 plus 4. So what does that give you? Well, 6 plus 4 equals 10. So all I did was take the number it gave us and substituted it in for x. So with that being said, let's try to put in another one. Our next one says we got f of negative 3. So guess what we're going to do? We're going to plug it in right here, and it's going to be negative 3 this time. And negative 3 is going to take the place of x again. So we're going to go 2 times negative 3 this time, plus 4. It's negative 6 plus 4, which gives us a negative 2. So this part is how we found A, and this part is how we found B. So again, I just took the function it was given us, f of, and plugged in for x, plugged in for x. It's pretty straightforward. Don't try to like overwork it or anything. I mean, all you are doing is taking the function it gives you and plugging it in anywhere that you see an x. Okay. So with that being said, let's take a little look, if we could, at example 6. And I think this might be the final example here. It says find the range. So we got another function. Yikes. This looks like a dandy. So we got g of x, which also can stand for anybody. You over in the corner. Well, I think it might equal y. Oh my goodness. Oh my goodness. This guy, how did you know it was y? Huh?
That was easy.
You are blowing this out of the water. I just like math so much. Well, stop making me cry. Alright, so, like I said, it also can stand for y equals. Okay, so we're given g of x equals 3x minus 2. But this time we're given 3 different functions. So, negative 3. Here's what I want you guys to see, okay? All you are doing is you're going to take this right here and set your problem up like this. X and g of x equals 3x minus 2. What do you guys think you're going to do? Well, I'm glad you asked. You're going to take what was given to you, negative 3, 0, 2. So negative 3, 0, 2. You're going to plug these in anywhere you see an x and solve it. So your first one's going to be 3 times negative 3 minus 2, which gives you what? And also, I'm going to make this column over here so you can see how you get your y. So we got 9, negative 9, plus negative 2 gives us negative 11. Okay? So we can cross this one out. Now we're going to plug in 0, so that means it's going to be 3 times 0 minus 2. So 0 minus 2 is just minus 2. Now we can cross that out. Now let's do 2. So it's going to be 3 times 2 minus 2. So that gives us 6 minus 2, which is what? 4. Well, guess what? We just found all of our order pairs. We got our range right here. And now we got our domain right here. And our range right here. And we can set these up in order pairs, which is going to be negative 3, negative 11, 0, negative 2, and 2, 4. And guess what, guys? That is your function. So we found our range, our domain, and we found our function. And is it a function? Yes, because what? Somebody? Guy in the corner again? Well, you don't have any x's that are the same. So what you're saying is none of these are the same? So it's a function? You are correct. All right, well, golly bum, that's awesome. This guy knows his stuff. Well, guys, it looks like class has come to another end. It's been my pleasure hosting you as always. And as I mentioned time and time again, if you have any questions, please don't hesitate to call me, text me, or FaceTime me. Definitely want to make sure you guys are understanding the material. And I appreciate your guys' cooperation. And again, I apologize for the inconvenience of having to do lessons like this. But again, so thankful that we're still able to meet. And hopefully we've all learned something from this experience. And I hope that if you guys have any questions, you know how to reach me. With that being said, ta-ta for now.